This video introduces the topic of finding zeros. The learning outcomes are to use synthetic division to divide polynomials by x minus a, and to use the remainder theorem to determine the values of p of a, and to linearly factor polynomials using various theorems. The theorems that will help in factoring are the factor theorem that will determine if x minus a is a factor of the polynomial p of x, the rational root theorem, which helps decide possible factors for the polynomial. So you want an easier way of dividing polynomials? We do have an easier way, but it is very limited. We can use synthetic division when we want to divide polynomials by a divisor that is in the form of x minus some number a. So let's do the same problem of 3x cubed minus x squared minus 150 divided by x minus 4. But use synthetic division as it meets the requirement for the divisor that is in the form of x minus a number. First, we need to set up the synthetic division by writing only the coefficients of our dividend. This means we have to write 3, -1, 0, and -150. Remember that the 0 is for the x term that the polynomial is missing. So we find that we have a coefficient of for the x cubed term, the x squared term, the x term, and the constant term. If the polynomial had the highest power of 5, we would need a coefficient for the x to the 5th, for the x to the 4th, for the x to the 3rd, for the x squared, and for the x term, as well as for the constant term. To complete the setup of our synthetic division, we get our divisor and equal it to 0. So we have x minus 4 is equal to 0, and solve for x, which will give us x is equal to 4. We place a positive 4 in the small box. Now we are ready to do synthetic division by first bringing down the first coefficient, which means we bring down the 3. Then we multiply the 4 times the 3 and place the 12 under the next number, and then we add. -1 plus 12 is equal to a positive 11. Now multiply 4 times the 11 and place the 44 under the next number and add. 0 plus 44 and we get 44. Now multiply 4 times 44 and place 176 under the last number and add -150 plus 176 and we get 26. These numbers that we have been writing down should look familiar, so our quotient for our division problem is right here at the bottom. We just need to add some x's. Since we started with x cubed, we will start our quotient with x squared, 1 power less than the original dividend. Then we decrease by power to get 3x squared plus 11x plus 44. And the last number is the remainder, so we can write our divisor under it to get plus 26 over x minus 4. Now I did this problem to show you a couple of things. One thing we found was that we can now quickly divide polynomials by factors that are in the form of x minus a. The remainder theorem states that the remainder you found when dividing is equal to plugging in a into our polynomial. In other words, if our polynomial is p of x is equal to 3x cubed minus x squared minus 150, we can plug in 4, which is the number that we used in our synthetic division, into our polynomial, and we get p of 4 is equal to 3 times 4 cubed minus 4 squared minus 150. And if we simplify this, this ends up being 3 times 64 minus 16 minus 150, which is 192 minus 16 minus 150, and that equals to 26, which was our remainder when we did our synthetic division. The remainder theorem means that we can use synthetic division instead of plugging in numbers.